For question number 7, I'm going to start by drawing a diagram. So on the y-axis we have intensity. And on the x-axis we have the wavelength. So classical physics had predicted that the intensity of radiation that was emitted was a function of wavelength. That at a particular temperature, as wavelength increases, intensity of the radiation decreased. So they had a curve like this. So they had predicted that with UV, for example, which has a very short wavelength, that the intensity should be very high. However, Planck solved this UV catastrophe by proposing the idea that there's an exchange of energy between matter and radiation, and that this occurs in quanta, and that radiation of a certain frequency can only be generated if the oscillator, so the electron or the atom, of that frequency has acquired a minimum energy to start the oscillation. So his curves look like this. This is the lowest temperature, this is a higher temperature, and this is the even higher temperature. So he had predicted that at a certain temperature, there will be a peak intensity. However, at shorter wavelengths, after on the left of this peak, the radiation intensity will actually decrease because there is not enough energy to stimulate higher frequency oscillators. Therefore, he solved the UV catastrophe by indicating that there will be no high energy radiation emitted, even at short wavelengths.